Okay, question number 9. A group of 10 children includes one pair of brothers, Elvin and Bobby, let's say A and B, and one pair of sisters, Catalina and Daniela, let's say C and D. The children are to be seated in 10 desks, which are arranged in 2 rows of 5 as shown in the following diagram. Elvin and Bobby, A and B, must be seated next to each other in the same row. Find the total number of ways that children can be seated. So A and B must be sit next to each other, which means that we can apply the concept of blocking the seats. We can block the seat only for A and B, like this, like 1, 2, 3, 4, 5, 6, 7, 8. Notice that there's only 8 ways of blocking seats for A and B. And also A and B can switch position in blocking the seat. So there are total number of ways blocking seat is 8 ways, and the A and B can change their seat in one block. So there's going to be 2 factorial, and the rest of the student can be seated in any order. So 8 rest of students can be seated any order. So it's going to be 8 factorial. So calculating this number will give us the first answer. 8 times 2 factorial is 2 times 8 factorial go to mass factorial. So 6, 4, 5, 1, 2, 0 cases. Okay, question number B. After an argument, C and D must not be seated next to each other. A and B must still be seated next to each other. Find the total number of ways children can be seated. Okay, let's start from here. C and D must not seated next to each other. C and D must not seated next to each other. The number of ways C and D must not sit next to each other is the total number minus total number of ways minus C and D sit next to each other will give us an answer that C and D must not be seated next to each other. So start from blocking seat for A and B. There are 1, 2, 3, 4, 5, 6, 7, 8 ways of A and B sitting next to each other. If A and B sit over here, we can block seat for C and D. So for case A and B sit to here, this position, we can block the seat for C and D 1, 2, 3, 4, 5, 6 cases. So if A and B sit over here, also this is symmetrical, right? There are 6 cases. Here and here, all these 4 cases are the same. The other cases A and B sit next to each other is A and B. If A and B sit in the middle seat over here, 1, 2, 3, 4 of these cases, and C and B can be seated. If A and B sits over here, C and D can be seated over 1, 2, 3, 4. There are only 5 cases for 1, 2, 3, 4 cases of A and B. It's kind of complicated, but as you see, answer B start from here. We start from this answer here, 6, 4, 5, 1, 2, 0. 6, 6, 4, 5, 1, 2, 0 minus we can find a way of a case number of ways C and D sits together. So it's gonna be still gonna be 6, 4, 5, 1, 2, 0 minus if delete everything. Okay, if A and B sit over here, 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 for those 4 cases we have C and D sit over 1, 2, 3, 4, 5, 6 cases, right? So in that 4 cases, A and B sit each other. C and D can sit each other 6 cases, and of course A and B can switch position 2 factorial times C and D can switch position 2 factorial. And then the rest of the kids, there are 6 remaining kids can sit it in any order. So this is going to be 6 factorial plus if A and B's can be seated over 1, 2, 3, 4 in the middle seat. For those 4 cases, it's all symmetrical. So if A and B sit over here, C and D can be seated only for 1, 2, 3, 4, 5 cases. So for A and B seat and the middle seat, those 4 cases, there are 5 cases C and D can be seated together. Of course, A and B can change C position, so 2 factorial times C and D can switch position 2 factorial, and the rest of kids can be seated in any order. So we can find this number equals, so this number minus open parentheses 4 times 6 times 2 times 2 times 6 factorial plus 4 times 5 times 2 times 2 times 6 factorial close the parenthesis will give us 518,400 number of ways.